So, first part of this lecture, I'm going to keep talking about Git. So I was kind of halfway or 2/3 of the way through talking about Git last week, and I'm going to finish that off now. Okay, so I want to walk through, just see if you're following me about how all these remote repos, local repos, etc. work. So I've got a file. So I've got some files, and I want to make a change to one of them. So I change one of these files to red. So that indicates I made some change in it. And I always do that in my working copy. So it's my local program or local files in my working directory. Before I do anything else, I should compile this. I should test this, make sure it works. Okay, but it does. And then I'm going to do a git add and a git commit because I want to share this file with Andrew. Okay, so Andrew is, many of you have a tutorial with Andrew, so he's one of the TAs in the course. He and I are collaborating to get something done. So I need to send this file to him, and I'm not going to email him or anything like that. That would be barbaric. I'm going to send it to him through Git. So I guess I've already given you the first thing. I should add the file, which tells Git, okay, I've got a change in this file that I would like to get into the repo, and then I commit it. And committing it is going to put it into my local repo. Okay, so I've given you the first step. What do we do next to get this file to Andrew? So let's type it in the chat. Okay, so I already see that was fast. Okay, so you guys made that decision in a millisecond. You said git push. And you're right. I have my own copy of the repository. I have a local repo, which is my own essentially cached version of the remote repo that I'm working with. Andrew can't see it, so if I want to get this file to Andrew, I've got to push it. So I push it, and now the remote repo has a copy of that updated file. Okay, now what should I do? So what's the next step? What does Andrew have to do? Okay, right. So Andrew has to do a git pull or a git pull -r. They're very similar. The only difference is it is exactly what the revision history looks like. As I said last week, we find the git pull -r generally gives you a kind of nicer linear revision history, but both of these are going to work. Okay. So, but let's say before we do that, and it makes it a little more complicated. Andrew's been working away, so he made a change. So this purple file, he changed in his local working copy. He compiles, he tests, it works. So he hasn't just been waiting around for me to send him a file. He's been doing work on his own. He wants to get this change into the code base as well. Okay, so what should Andrew do? So what do you think Andrew should do next? He wants to get this purple file to me. So if you got any ideas, just type it in. So push, he can't actually push yet. The reason he can't push is push connects the local repo and the remote repo. So before he pushes, he has to do something else. Yeah, he has to add the file saying I've got a changed file, and then he has to commit it. Okay, so he adds and he commits. So that got into his local repo. That worked fine. And then I see various people saying, okay, now push it. If you push it, you'll get into the remote repo. Sounds good. So he tries to push it, and he's going to get a message saying you can't. Basically, the message says that his local repo is out of date. There are changes to the remote repo that he doesn't have yet, so Git's not going to allow him to push his changes because he's not based off the latest code, the latest revision that is inside the remote repo. So it's perfectly fine, nothing bad happens, but push is going to complain, say you're not up to date. And I see people saying what he should do next. So he should pull. So he does a pull. Okay, he could do pull, he could do -r. I saw people in the chat saying the -r stands for rebase. That's exactly right. Just makes pull work in a somewhat different way. And as I said, you get a kind of cleaner revision history usually with this. But if we did pull without the -r, it's not horrible. That'll be okay too. So he does this pull. Now it's good that Andrew was working on one file, I was working on a different file. So Git is going to figure out that there's no problem merging our changes, and it's going to go ahead and put them in Andrew's local repo and in Andrew's working copy. So, and I see a question, if he pulls, do his changes get erased? No, his changes don't get erased. Git is pretty careful about not losing changes. So in this case, Git can figure out exactly what to do because we didn't change the same files. So there are no conflicts. Even if we change the same files, as long as we change different lines, it would be okay. So Git merges everything together. Andrew should immediately, well, what should he do now? He could do a push, but what should he probably do before he does a push? Commit. He doesn't have to commit. What he has to do is, check if it still works. He just pulled in some changes for me. What if my changes plus his changes are bad? Or what if I'm just a really bad coder and I just put broken code back? He wants to know that this still works. So he should build it, he should test it, and then he can do a push. And this push will work, and now the code is in the remote repo. So it's all good. Okay, so that's going to be your coding routine once you're working in a team, which starts next week. So you're going to do git pull, and again, we recommend this -r to get a cleaner revision history, or git log. So you get the latest code, you do something. You fix a bug, you enhance a feature, you do some amount of work, you build it, you test it. It all works, you're happy with it. Maybe your feature's not completely done, but at least it compiles and it doesn't break anything else. That's okay. So now you have to git add to say, I've got some changed files that I want to go in my next commit. You git commit to get into your local repo, and you git push to go to the remote repo. Sometimes when you do that, this push, whoops, this should be down here, but this push will fail if someone else has changed the remote repo code since your last pull. Don't panic. All you do then is you do a git pull, you build, and you test again to make sure everything's okay, and then you can retry the push. Okay, so you're going to do that over and over again. Before you start something new, you should do a pull-r or a pull. I'll recommend the pull-r so that you try to stay as up to date with what your teammates are doing as you can, because it reduces the odds of getting conflicts here. If you both change the same line in the same file, then you will get conflicts. You will have to do some more work, see the quick start to see what that work is. But you try to minimize that. So any questions on that? That's your basic workflow that you're going to follow through the rest of the course. In the quick start guide, so I see a question. The quick start side guidance says you should push right after commit, but git add isn't included in that. So git add is used to build up a list of, here are all the changes that I want my next commit to have. That might be one file. You might do one git add and then do a commit, but maybe you have to, the commit doesn't make any sense to do as one file. You changed 4 files, you need to add them all before you do the commit. So you kind of decide what is a logical granularity of commit. It should be something that is an update that you can write a message for and works. So you wouldn't do a commit that is, I put 1 file back, but I actually need to change 2 files in order for this to compile and work. You would change both files, you git add both of them, you do 1 commit. So hopefully that answers your question. So git add is essentially building a change list. This is all the stuff I want to go in the next commit. Okay, so I'm now going to talk about something you don't have to use, but you may hear a lot about it, so it's useful to know what it is. And that is branching. So let's talk first about what is the motivation for branching. Tony Stark's finishing off milestone 1. So it's working. He's just fixing a few last bugs, so it's not perfect, but it's pretty good. And Bruce Wayne wants to start work on milestone 2. But at this point, we don't want him to break something. So we don't want him making big changes, and then he breaks something, and then Tony can't submit milestone 1, which is due pretty soon. So we could say, Bruce, you can't do anything, right? We have to just wait until milestone 1 is submitted. But that's inefficient. So there's a better solution, which is called branching. Okay, so I'm showing you a picture of a little more detail of what the status of the Git repository is for both of them. So they've been working away for a while. So Iron Man's commits are in red and Batman's are in green. So they've each made a bunch of commits, and Git maintains those commits essentially in order. It knows that this commit, this change happened before this one, which happened before that one. So it's got an ordered list of commits. Every commit knows what came before it. And there are a couple of what are called refs by Git. So a ref is basically a pointer. It's a pointer in, not a pointer to memory, it's a pointer in Git repositories. So important refs or important pointers, there's one called master, okay? And master is a ref or a pointer that points to the tip of a branch. Tip of a branch means the last commit. in a change of commits. It's if you make changes, this is where you will build off of. You'll do a commit after this one. By convention in Git, master is the most important and longest lived branch. So you don't have to do it this way, but this is the way most people do it. Master means the long-lived code base that we're going to keep working on forever. In some documentation, you'll see them call this main instead of master. They mean the same thing. Okay, so most important branch, and this ref, which is a branch, just means I'm pointing at the tip, the last commit in this chain. There's another important ref called head, okay, in all caps. And it is a pointer to the branch you're working on. And every developer has their own head pointer. So right now, both Batman and Iron Man, their head pointers point at master. So they're both working on the same branch, and you can see that. You know, they're interleaving commits, they're working together. Okay, but now they want to change that. They want to change that because Iron Man wants to finish working on milestone 1 with little fix-ups, and Batman wants to go off and make some radical changes to get ready for milestone 2. So Iron Man's going to create a branch, and he does that with this command, git checkout, which you've already done before, but he adds this option -b, which means create a new branch, and you have to give it a name. So he's going to give the branch a name of finish M1. So that makes a new reference or new pointer called finish M1. So that's what we got down here. And this checkout command makes Tony's head pointer point at this new branch. So he's done 2 things. He's created a new pointer called finish M1, and he's made his head pointer point at it. There are no new commits. So both the master and this finish M1 are pointing at the same commit, revision 101. But now what's going to happen is whatever Tony does next is going to follow a different path of development. So let's see what happens. Okay, so this is the state after that branch command. They're both the master and this new branch, finish M1, are currently pointing at the same commit. Okay, so Batman makes a commit and a push, and he makes a new revision. And that new revision, so say revision 102, master follows it. So now the tip of the master branch is here. So that pointer has been updated. But finish M1 hasn't been. Okay, that branch doesn't come along for the ride. Now Tony makes a commit, and his commit goes into the repo, and the finish M1 reference is now updated. Okay, and they keep working, and every time Batman makes a commit, the master pointer is updated, and every time Tony makes a commit, the finish M1 reference is updated. So we've got basically now 2 parallel lines of development that branched off from this revision. So they can work independently without getting in each other's way. Let's see. So that has a bunch of advantages about not getting into each other's way, but there's also a disadvantage. Let's say that in this revision 106, Tony finds a significant bug. This shouldn't be fixed just for milestone 1. This should be fixed in the code base, the master code base that's going to live on, and they're going to use for milestone 2 and milestone 3 and so on. So he could try to remember what are all the code changes he made and do them manually on the master, but that's inefficient. So he can use the git merge command to automate this. So what he does is first he does a git checkout master. This command basically updates his head pointer and his working directory files so that he's now pointing at the master. Okay, so he's left his branch of finish M1 and he's gone back to the master. And at this point, he can now type this command, git merge, and he gives the name of a branch. So he says, I want to merge in whatever is on this branch, finish M1. So Git figures out what are all the changes in this branch and basically brings them in to the master branch. And if there are no conflicts, this will work fine. They should immediately test afterwards. But he's basically avoided having to do this. Manually. Okay, now you have to be careful with branches. So the way I've described branches, they sound pretty good, and there are advantages to them. Basically, Tony and or Iron Man and Batman have been able to work pretty independently, and then now we've decided that these fixes that Tony made on this finish M1 branch should be brought into master, and we use git merge to do that. So it all looks pretty good. But what you have to be aware of is if they work independently the longer they work independently, the more commits Tony makes on this branch, the more different the code is becoming, the more changes there are on each of these two branches, and the more likelihood that there are conflicts where Git can't, they both change the same line, Git can't figure out how to put it together. There's also chances that even though there is no conflict, that they've made changes elsewhere in the code so that when they put things together, there are logical flaws and it doesn't pass the tests anymore. So it's not a good idea to keep your branches long-lived if you want to merge the changes back in later. So if you branch, keep them short. And what we recommend in this course is you don't really have to branch. You can basically just be constantly reintegrating with each other. We're not going to penalize you if you do, but students often get into trouble by not reintegrating often enough. So be careful about that. I see a question is, yeah, I think I'll answer that question afterwards. So I see a few questions. Maybe ask me that after the class if you're still not clear. So when you're developing, try to avoid long-lived branches, but there are some branches that live a long time for good reasons. So let's say you're releasing a large software system. In that case, you need to do a lot of final testing before you release it. And you do that normally on a release branch. So you've been working away on the master branch. When you think you're ready to release the code to your end customers, you make a branch and you say no major features now to this branch. We're just going to do a lot of testing on it. And while that testing is going on and bug fixing is going on, you can keep doing development on the master branch. So this is exactly what Tony and Batman did. But in larger companies, there might be a lot of people working on this release branch, and we might do testing for quite a long time. So when you're going to do a release like this, so Windows 11, for example, so you're going to branch the Windows code base and say that is Windows 11. It's going to take you a while to test Windows 11. You're probably going to send it out to hardware manufacturers, etc. So how long do you need? The sooner you branch, the more time you have for testing and stabilization, but you have to fix bugs in two places. So all your developers become less efficient. And as that branch lives for longer, the chances of being unable to automatically merge changes goes up. You're more likely to have conflicts. When I worked at Altera, we would branch 3 months before a release of Quartus. So as I said a couple of times, Quartus is big. When I was there, by the end of my time there, Quartus was 11 million lines of code. The cost of bugs was very high. It's a CAD system that's building hardware. If there's a bug in the CAD system, it can actually build hardware that doesn't work, which is really hard to debug and really annoys customers and can be dangerous. I mean, some of the things that sometimes kept me up at night is I knew that these chips were going in surgery robots, airplanes, because I would talk to some of those customers. So you really don't want bugs, particularly bugs that would produce incorrect hardware. So we would take 3 months before the release to stabilize. It did create extra work. My preference is branch kind of as late as you can, but you can still get all of your testing done, and it reduces duplicate work. Okay, so that's it for talking about Git. There are lots of references online, so make sure you've read through the ECE 297 Git Quick Start Guide. The first 11 pages are all about the command line. The last part is about if you want to use the NetBeans GUI. Most people use the command line, which is fine. It's actually more portable, so it's probably the better thing to learn anyway. Read all of those 11 pages and make sure you do the walkthrough in milestone 0. There are a lot of online resources. My favorite Git reference is this Atlassian Git tutorial. It's very easy to read, gives a reasonable amount of detail without being overwhelming. If you want very detailed references, this Pro Git book can be read online for free. It's extremely detailed. It's a multi-hundred-page book, so it's really far more than you need, but it's there. And then the Git command reference, which is also very detailed. But I do find this Atlassian Git tutorial is a lot easier to read, so that's my preferred book. Okay, so the last thing I'm going to do is I'm going to do a quick demo of just typing a few of these Git commands. And what I'm going to do is I've got a changed file on my VM, okay? When you use the virtual machine, you don't have to use it, but if you use a virtual machine, you have your local repo on your home computer, okay? And it's connected to the UG machines through the remote repo, which is stored in basically shared directories on the remote repo. I also have a computer, I have a UG session open. And on the UG machines, they all share one file system. So no matter which UG machine you log into, you're always connected to the same local repo and the same working copy. But basically, if you use a virtual machine and you use the UG machine, you're communicating through Git as if you were two different people. They basically communicate through the remote repository. So that's maybe useful to know if you use both the VM and the UG machine. It's also useful for doing a demo because I can essentially behave like I'm two different developers. Okay, so let me quickly show you that demo. Okay, so I'm on the VM, and okay, so I'm going to make my milestone 0. Okay, it's already been built, and now I'm going to run ECE 297 exercise. So I just ran ECE 297 exercise 0. That's val grind passed, it's green, but this other test, what's called the execution test, failed. And I go back here, why does it fail? Basically it says I didn't have all the expected output strings. Okay, I expected to have this center of mass output and didn't find it. Okay, so I've got a bug. Let's do a git log to see what's here. And you see I've made a bunch of fixes. So I've made some fixes. You can actually see some of the terminology we just used. So I'm working on the master branch is what this says. And it said also that it came from the remote repo master branch. Origin means remote repo. Okay, so you can see that I've made a bunch of changes, but there's something still wrong. And happily, I know what the bug is. Okay, so I'm going to look at this, and the bug is actually this 7 is supposed to be a 5. If you read the milestone 0 handout, one of the things it tells you is we got the wrong polynomial, you're supposed to change it. So I just changed it. I could build through NetBeans, but I'm just going to hit the command line. So I'm going to type make. If I hit exclamation mark ECE, it'll run the last command that started with ECE. So it's a fast way to rerun exercise. And now everything passes. Okay, so great, it works. And so I need to add that into my repo. Okay, this is my local working copy. So let's just do a git status, see what it says. So what it says, first it says my branch is up to date with the remote repo. So my local repo is up to date. And it says I have a file that I've changed, this main.cpp file, and I haven't added it. It won't be in my next commit. So I'm going to add it. So I'm going to add git main. It's not in the same directory, so I'm typing the same full path to it. So I just added it, and now I'm going to commit it. And I basically say I want to commit it with this message. So basically fix center of mass polynomial. Whoops. Sorry, I did not try this in advance. All right, let's try that again. Whoops, okay, better not do that. I use the arrow keys to go back to old commands too. So let's try that one. Okay, that worked. Okay, what should I do next? Git config just basically, I see people typing questions, what do these things do? Git config just stores basically variables that you're gonna need for a long time. So I just told Git who I was. I just set up this VM. Okay, so let's do git status again. Git status is your friend. And it basically says, I'm ahead of origin master. So my local repo has changes that aren't in the remote repo. That's what it's telling me. And it says, there's nothing in my working directory that's not in the local repo. Okay, so what should I do? I want to get this code to basically my partner, which is actually me on the UG machines. What should I do? Yeah, so I should push. So let's do a git push. Okay, it asked me for my password because I'm on a VM, so it doesn't know who I am. Anyway, it just put it in. So this says it put it all into the remote repo, so it succeeded. Okay, so now let me shrink down the VM and let me bring up the UG machines. Okay, so this is me on VNC on the UG machines. Okay, let's do a make. Let's do, I'm going to run ECE 297 exercise here. Okay, and it failed. It failed because I don't have the change yet. I made that change on the VM and I pushed it to the remote repo. I don't have it here yet. Again, on the UG machines, I'm working off a different working directory. I'm working off a different local repo. It's like I'm one of my teammates. So I have my own team. Okay, so what should I do? Let's do git status. Git status is our friend. Let's see what it says. Okay, so maybe this is interesting. So this basically says I'm on branch master. That makes sense. I want to be working in the master branch. It says that my branch is up to date with origin master. It says I'm up to date with the remote repo, but I just put something in the remote repo. I pushed it from my VM and it fixed this problem, but this says that I'm up to date. What's going on? So people have got the right idea. Do a git pull. If I do a git pull -r, it's going to fix this. But why is it telling me that I'm up to date with the remote repo when I'm not? Yeah, git status talks to the local repo. So git status does not know that there are changes in the remote repo because it doesn't actually talk to it. It has a cached version of the remote repo. So I could do a git pull. I can also do another command if I want, which is part of pull. Pull does this automatically. If I want to do a git fetch, okay, git fetch basically just grabbed any changes that are in the remote repo and made sure that my local repo knows about them. Now when I type git status, it actually says I'm behind the remote repo by 1 commit. Okay, so now it's up to date. So that's an important thing to remember. It's something that confuses people when they're working in a team. The local repo is a cached copy of the remote repo. You have to explicitly use pull or fetch to get the changes. Okay, now I want to get the changes. I don't want to just update my cached version. I want to get them in. Type make, it built. I'm going to rerun ECE 297 exercise, and it passed. Okay, so it all works. Yeah, I see some people asking, what does git fetch do? Git pull is actually a convenience command that does a fetch and then a merge, or if you do git pull -r, it does a fetch and then a rebase. So the first part of pull is fetch. What fetch does is it goes to the remote repo, gets the latest data, and makes that information available to your local repo, but it doesn't actually integrate it into your working files or do a merge. Okay. Usually I just use git pull, but I wanted to show you the steps here. Okay, so that's all I had to say, and I'd like to hand it over to Ken now.
Great, thank you, Vaughn.